Hey guys, just thought I'd do another video here of this Andrey Melnichenko circuit. This is what Chris did, and here's the board that he designed. I just finished getting all the parts for the board. It actually turned out quite nice. I don't have the bobbin yet for the coils. I just threw a coil together here just to muck around, play with it. It doesn't have the capacitor plates on this or inside or anything. It's just two windings. So I'm not expecting this to work. I just wanted to see how the circuit would react to the two coils, and it seems to be reacting how it should be. So I'm kind of excited to get the bobbin that I'm supposed to use for this and wind that correctly to the correct inductances. This is like 21, I think, millihenries, and this is 56, but it depends on what frequency you put into this. I have a pretty nice LCR meter here that I can change the frequency on. So it's actually a wide range of inductances depending on the frequency you put into it. But anyway, that's doing the job just to see how this board is working. So I find if I just put, what do we got there? 2.6 volts in, right? That gets the thing lit up. They're 3-volt diodes in series, so they light up with just a little bit of voltage, which is kind of unusual, because if you just put them on a regular DC power supply, to get them that bright, they need over 3 volts. So they're kind of brighter in this circuit, just the way that it is. And you can see on the oscilloscope I've got a yellow, blue, and the purple trace, or pink trace. So the pink trace is on CN3, which is on pin 13 of the the 4069 chip. The blue trace is on the pin 12, okay, of the 4096 chip. And then the yellow trace is over here off the DC converter off pin 1. Okay, so that's where we'll see our fine oscillations when we get that going. So right now it's just, I'll show you the difference just if you change the voltage in. Like that's 2.6 volts. That's 2.5. 2.4. You can see it really changes quickly. The light bulbs are still lit up at 2.4. 2.3 they're getting pretty dim. 2.2 they're really dim. They shouldn't even be lit there. But let's just go back to 2.4 and see how it dropped down a little bit. There's a little resonant point there, see that? But 2.6, 2.5, 2.6, that's where it seems its sweet spot. And you can see everything seems to be working correctly there. But then if I want to see the oscillations on the DC power supply, I think because this coil isn't wound right, I'm not getting the right magnetic field, so I'm going to bring a third magnetic field in with this magnet, and just watch what happens when I bring this in, and I'll show you up on the screen. Just going to bring that in, a little quick there, but you get the idea. Now I've got the oscillations on the DC converter, and if we stretch that out, you can see that's about 131 kilohertz. Anyway, I just wanted to show you that, and then also the fact that just by moving this magnet around, like if I just peel it off a little bit here and just play with it, just right here, you watch what it does to the waveforms. You can really mess it around, change it quite a lot just by moving this magnet around. It's quite interesting, fun to play with. Also makes these look how bright they get when you put the magnet on. So anyway, just wanted to show that, having a little bit of fun here. It's not ready for prime time yet, but it's a lot of fun to play with. All right, cheers.